Hello, I'm Mark Ryan, the marketing manager for the Shepherd Color Company. I'd like to thank you all for joining us today for our webinar, IR Pigment Technology for Improving Plastics Recycling. We're very excited about this technology that can improve the recyclability of plastics. This is especially important nowadays because one of the important attributes of plastics to make them sustainable is their recyclability, the ability to use them over and over again without degrading the properties and to continue their use. By some accounts, if we increase the amount of recycled plastics, we may actually be reaching the point of peak production of plastics, of new resins. So this recycling of older resin is critical to improving the sustainability overall of plastics. As we can see here, we have some bales of post-consumer single-use plastics. And this would be an example of the mixed stream, all different polymers together, all the different colors. What would happen is after you put them in recycling bins, they would go to a processing facility and they would be put on a conveyor belt. And one of the oldest ways and most common ways is that there will be people there that will actually pull out the different plastics and sort them and remove trash that can't be recycled. So in this way, they improve the recycling stream. The more modern way to sort the plastics is to use electronics to actually look at the plastics and then interrogate them with signals, look what reflects back, and then determine what the polymer is. Well, there's an issue with that is that many dark colored plastics, black plastics, defeats the detectors and the polymer cannot be detected. What we are excited about is that the use of our infrared reflecting pigments makes it so that these plastics can actually be sorted and recycled. That's very important because if the plastics aren't identified, they cannot be actually used in the recycling stream as efficiently as they could. So lots of times they'll end up in landfill. And we all know that in the time of COVID, where we've gotten a lot more take home and bring home packaging, we all have a lot more of these black plastic containers. These are almost ubiquitous because it was found that the use of a black plastic like this makes the food look fresher and more appetizing. So it's very important that we keep these black plastics, which are sometimes about 10% of the plastics being used in single-use plastics. We need to keep them in the recycling stream to improve the sustainability of these plastics materials. So what exactly is going on? Well, as we showed in that schematic of the conveyor belt of the plastics coming down, there is actually an IR emitter that sends out near infrared wavelengths of light that hit the plastic. The issue is that with standard black plastic, that infrared energy is absorbed. If an IR emitter hits a black plastic that is actually colored with an IR reflective black pigment, that energy reflects back, can be detected by an IR detector, and fingerprint of the resin can be determined, and then it can be sorted. So how exactly does that work? We have a graph here where we have the percent reflectance on the vertical axis from absorbing at the bottom towards more reflective towards the top. And then we have it by wavelengths across the horizontal. So we have the UV range from 200 to 400. From 400 to 700 are the visible wavelengths of light that we use to determine color. That's what our eye sees. But past around 700 nanometers is the near infrared, which our eye cannot see. So what we see here is that a typical polyethylene pigmented with a carbon black, which is the standard black used in almost all plastics. It absorbs in the UV for stability. It absorbs in the visible part of the spectrum so that it's dark in color, but it continues to absorb as it goes across the near infrared wavelengths. What we see here is the same plastic. If we use a different pigment, if we use an IR black pigment, it absorbs in the UV for stability. It absorbs in the visible part of the spectrum, so it is a dark color. But once we get into the near infrared, where we can't actually see these wavelengths, there's these reflectance and absorption curves throughout the infrared part of the spectrum. So that means that if we have different polymers, they can all be absorbing in the visible with the infrared reflecting black, but because of the infrared reflecting and scattering properties of the IR pigment, you can see the differences in the reflectance and absorption areas at different wavelengths for the different plastics. Here we see one curve for polystyrene and one for polypropylene. All this is happening where we cannot see it with a visible naked eye. So they all look black in color, but they have different absorption curves, different fingerprints in the near infrared. And those scanners can look at these different wavelengths and look at ratios of reflectance and absorbance, and then determine what the polymer is. So we can see here the polypropylene, the polyethylene, even nylon has a different reflectance curve, and of course, PVC. But as you can see here, in the visible part of the spectrum, they're all absorbing for a dark black color. So when are these colors an issue? And the Association of Plastic Recyclers has found that these IR scanners, they have an issue when the plastic in the near infrared reflects less than 10% of the energy at each wavelength. Or a good proxy for that, if you don't have a near infrared spectrophotometer, is that the color, the L value, which is the lightness scale, is under 40. So this kind of color patch represents kind of a neutral A and B value and an L value of 40. So plastics under that are darker than this color can have a problem. So definitely blacks, is pure black mass tones will have a problem, but also other colored dark colors that aren't just pure black will also have issues if they're formulated with a standard black pigment. So we at Shepherd have found a product that we have optimized. It comes out of our Arctic line of IR reflective pigments that we've been selling in the plastics and the coatings market since the 1980s. But this product is optimized specifically for this recycling process. And we call it Black 10P 925. And we kind of picked the 2 and the 5 because these pigments are non-warping. They in polyolefins and polypropylenes, they do not cause warping. And also in the olefins, you can't use dyes, so you have to use a pigment. So this product is, as we talked about, is a black color. It's optimized for that jet mass tone. It does have a good, strong tint. It's non-warping. It's also non-magnetic, so it won't trip any of the safety detectors in the processing line as the plastics go by to keep metal out of there. Some pigments that are IR reflective have magnetic properties which can trip those sensors. And also, like all of our other pigments, they're high heat stable. So that means they can be processed in a lot of these different polymers, and they can be used time and time again, and they won't degrade. So why is this 10P925 the ultimate product for your use in recycled dark color plastics? Well, here we have a graph where we have the mass tone, the near IR reflectance. So if we're just looking kind of at the cumulative total of the reflectance from 700 nanometers out to about 2,500 nanometers, and we look at the mass tone A value, so how red something is. And we often use this mass tone A value as a proxy for how brown a black will look. So if you have the higher the A value, the redder it is, the browner that it will look. So what we want to do here is we want to have more reflective, and we want to have the most jet color. So the optimal products will be up towards this corner. So the carbon black is very jet. It's very, we all know it makes a nice jet mass tone color, but it has only about 5% reflectance in the near infrared. So it won't be acceptable for sorting by the near IR sensors. There are the pigment black 33s. They have enough reflectivity, but a number of these have magnetic properties. which preclude them from being used on some lines. And then what we have here is the Arctic line of pigments that we have used for a number of different. The Black 10G996 has been our standard blue shade jet IR reflective black with high reflectance. But what we've done is we've improved that. We've made it less of an A value and increased the reflectivity a little bit to for our Black 10P925. So what that means is that we have plenty of reflectivity for the discernment of the plastics, and we have a nice jet mass tone, jetter than any of the other, less red than the alternatives. So this makes it an excellent colorant for mass tone colors. Here, this looks a slightly different graph to kind of differentiate the products, because it's always hard to put up black panels and actually discern on a screen what the difference is between them. So on the horizontal, we still have that A value. So how red something is, more red towards the right-hand side, more neutral towards the center. But instead of reflectance, TSR or near IR reflectance on the vertical, we have the B value. So bluer in shade towards the bottom, less blue, more yellow towards the top. So in this, what we want to do is carbon black is has a very low L value. It has a very low A value, and it's on the blue side. So it gives you a nice jet black color. And what we found is that looking at these A and B properties, our Black 10P925 has that excellent balance of the A and B value. So of all the IR reflective blacks, it is by far the jettest option for use in these plastics. And that's why we're very excited. So for the OEM applications, for these black trays, that would make an excellent choice for in polypropylene, polyethylene, in PET. So that was looking at the coloring mass tone material for usually original equipment virgin resin. So there's also the other side of the equation is post-consumer recycled material. So if the sorting of the material hasn't been done by color, you'll often get in kind of a medium gray color to work with. So that can be kind of a random type color. So to help do two things, we want to do two things at one time. We want to reduce the L value, make that a darker, more aesthetically pleasing color, but we also want to keep it IR reflective, so that if it's used again, it can be recycled and identified and continue to provide value in the revenue in the recycling stream. So this graph looks at the L value of a tint. So we take the pigment, one part of the black pigment with 4 parts of white, and then we put it in the plastic and process it so we get the color fully dispersed, so we make a gray color. So instead of a mass tone with the black pigment by itself, this is looking at the pigment mixed with white. So the Black 10P925 has a fairly high L value. So it has a deep dark mass tone, but it has when you mix it with white, it's not quite as dark as some of our other options. So the best pigment for this is you would want one that has a low L value. So when it's mixed with the white pigment, which gives you the darkest color that you can have. And that would be our Black 10P950. So it is a little bit warmer in tone, but it actually tints out. It actually appears to be a nice, fairly medium gray kind of color when it's just mixed with white. So this pigment, the Black 10P950, if you're coloring PCR, would give you the best bang for the buck if you're looking to get it darker and more aesthetically pleasing. So the difference between a 66 L value and a 56 L value is around about a 50% reduction in usage to get to the same L value. So the Black 10P950 makes an excellent choice for coloring post-consumer recycling material. So we think of these as kind of a 1-2 punch when it comes to coloring recyclable plastics and making them compliant with IR sorting machines. The Black 10P925, the Jettis mass tone for OEM materials, has the most neutral but weaker tint. And then the black 10P950, you wouldn't necessarily go with it as your first choice for making a dark black by itself, because it has more of a red undertone to it. But it tints out to a nice, strong, low L value. So you can use less of it. It's more economical to use. So both of these pigments are IR compatible. They're not IR absorbing. They help scatter the infrared energy so the sensors can detect the plastics. They have a number of food contact approvals all around the world. They have registration approvals so that they can be used in a lot of different countries. They're on the list like TSCA, and they're REACH compliant. Pretty much all around the world they can be used. As we mentioned earlier, they're not magnetic, so they won't set off any of the safety equipment to keep metal shards out of the processing equipment. And they're also non-warping. They don't contribute in the olefins to any of the warping or dimensional instability. And like all of our CICPs, they're high temperature stable. So as we said, they can be used in recycled plastic over and over again, and they're not going to degrade and give off any kind of odd species, or they're not going to change color during processing. So we're really excited about those. That's because we have to increase the recycling of plastics. And if you color your black plastics with carbon black pigment, you've broken that change. They're no longer in the recyclable, optimal recyclable properties. With the IR reflecting black pigments, you keep that chain, you keep the plastics in the recyclable, and you make the most out of that recycle stream. So when it comes to all these black plastic containers, we have to stop the plastic black hole of potentially getting removed from the recycling stream and sent off to landfills. So thank you very much for joining me today. So we'd like to know what the next step would be. Would you like to be contacted to learn more about these? We have a number. This was just meant as an introduction to this technology. We have a number of different projects where we can talk to you about increasing the opacity in thin-walled containers. Carbon black is an excellent opacifier, and the IR pigments can have slightly less opacity, but there's some tricks that we've learned to improve that opacity in the thin wall containers. Ways to improve the jetness of the IR blacks and still be compatible for the recycling streams. And then help in coloring the PCR material. We'd love to hear a little bit more about, because of the variations and all those streams, about ways that we could help you. And just the overall use of the IR blacks in recycling. So most of you probably joined us through our Knowledge Center on the Shepherd website with our virtual trade show booth. You can click on the information button next to the banner that was the link in for this webinar, and that will take you to a survey, or you can type this survey, this URL into your browser, and you'll be taken there. We have a number of different questions. Some of these, like we mentioned about the projects we might be able to run, kind of where you are in your process of making plastics more recyclable with the IR technology. So once again, my name is Mark Ryan, and on behalf of everyone at the Shepherd Color Company, I'd like to thank you very much for joining us today. And we look forward to working with you on your project on helping to improve the sustainability of plastics. Thank you.